Hello everyone. I want to talk about section 4.3, reaction stoichiometry. This might be one of the most important sections of this course in that the ideas here are very important to the material that comes after this. So the rest of this module will be based on understanding the ideas in this section. So it's very important to understand these ideas going forward. They will also come up in later modules. So the idea of reaction stoichiometry will be very important. So let's talk about the learning objectives, and then we can get into some discussion. Explain the concept of stoichiometry as it pertains to chemical reactions. Use balanced equations to derive stoichiometric factors relating amounts of reactants and products. And finally, perform stoichiometric calculations involving mass, moles, and solution molarity. So this section is combining concepts we have seen in previous modules. So previously within Module 4, we had talked about balancing equations. So that will be very important here. And in Module 3, we talked about the mole concept. The mole concept will be very important here. We're bringing those ideas together in this module. And then also kind of the unifying factor here is what we actually talked about in the first module on the very first day of class, which was dimensional analysis. Dimensional analysis is how we figure out how to put all of these pieces together. So just a brief definition before we jump into how this will work. The word stoichiometry itself is basically about how we go about measuring things related to chemical reactions with calculations. So we can make predictions for chemical reactions if we know something about them. So this is going to be doing a lot of math. So understanding chemical equations will be important. Also understanding ways in which we quantitatively measure matter will be important. As an example, we often start this discussion by talking about some kind of cooking. So here we're looking at an example of making some pancakes. So you have the various components of the pancake before it's made, and before it's made they are separate things, and then over the course of time you end up with pancakes. So what we can do is we can use this recipe to figure out, well, what if we wanted more than that? What if instead of 8 pancakes we wanted 24 pancakes? How would that change the recipe? So we would use the recipe to figure out, well, what do we need to do differently? So we would say, okay, for 8 pancakes, we know 8 pancakes. We needed 1 egg. So if we want 24 pancakes, we have basically a conversion factor of 1 egg to 8 pancakes that we then use to figure out how many eggs we would need. We would do something similar for each of the other components of that recipe. Okay, so these are basically the same idea of what we'll be doing with chemical reactions. But of course, in a chemical reaction, we have a balanced equation as opposed to a recipe. So the stoichiometric factors are showing the relationships between the different parts of the reaction. We can take any 2 parts of the reaction and make a ratio for them. So we can interpret this in numerous ways. We can say that the 2 here is 2 specific molecules, and the 3 here is 3 specific molecules. That's what we're showing here. But then if we increase that amount, it increases the same for each. So if we have 2 dozen molecules of NH3, we would have 3 dozen molecules of H2. And then, of course, what we're doing is scaling up to the mole concept. So 2 moles of NH3, 3 moles of H2. This is how we will typically relate them, is with the mole concept, and then we will convert from that to whatever else we need as necessary. Um, One thing I want to actually mention before we move on a little bit here is that as you're doing this within a balanced equation, this one has three things. You'll often have four or more components of a reaction. Not all of those will be important for every single question. So just by having a balanced equation, you have more information than you need. You have to figure out which part of that information is helpful, which part of that will get you to what you want. Whereas much of the information in the balanced equation will not be helpful. And as we look at some examples, that will become hopefully a little bit clearer. So there are some examples here. There are several examples. So the first example, we're looking at simply mole to mole. And there will be an example that I do of a different question going through that process. So please watch that video. But then also look at this example. And then here we're looking at molecules. So you can do an example of that. Here we're looking at masses, okay? So the mass concept we introduced, or the mole concept we introduced in Module 3, where we have a way of converting between moles and mass, that is also something we can do here. The difference is we have these additional steps. So definitely look at those examples. And then here, another example of mass. Again, I will have a few examples on Canvas of some of these as well. Please look at these examples, but then also if you feel like you need, when I say look at these examples, I mean open your own online textbook and look at these examples. But then also, if you need more, if you think you need more, watch the videos I'll be recording of some additional examples. I want to also point out this flowchart at the end. And this is a lot of information. So let's just take a minute to kind of take it all in. The mole concept is the most central concept that we will be looking at in this chemistry course, which is why at the start of this section I said this is probably the most important section. The mole concept is very central. We've already looked at this in a number of ways, and now we're kind of bringing some of those ways together in this section. So I want to spend a little bit of time discussing that. So at the very center of all of this is the mole concept. The mole concept is how we can, looking at a chemical reaction, talk about how one substance in that reaction relates to another substance in that reaction. So we're showing that here by looking at the stoichiometric factor. So when we say A and B, we're talking about two things in a chemical reaction that you care about. So you might be given something about A and asked to find something about B. To do that, you need to have the stoichiometric factor from the reaction. Now, in most cases, you're not going to be provided a question in terms of moles, nor will you be looking for something in terms of moles. Maybe you'll be given a mass and you're looking for mass. Maybe you're given a volume and you're looking for mass or volume. Maybe you're talking about the number of particles. So there's lots of ways in which we will have to do conversions around this central mole-to-mole conversion. Okay, so definitely watch that video, but then also realize that is not the end of it. You also have to get to the point of doing this middle step. Okay, so outside of that middle step, you have all of these other ways in which the mole concept can be related to things. If you know how many particles you have, you would use Avogadro's number. If you know the mass of a pure substance, you would use the molar mass. If it's not a pure substance, if it is say, an aqueous solution, you would use the molarity as that conversion factor to get from the volume of solution to the moles. Okay, and then likewise for whatever you're looking for, you would have these additional conversions. And then your textbook is also showing this kind of one more even step beyond that. If you are given the volume of a pure substance, you would convert to mass using density before getting to the point of using molar mass to convert to moles. That level of steps is probably not going to be something you will need at this point. There will probably be some homework questions where that comes up, but more than likely, you will have at most 3 steps at this stage. Later into the semester, we'll have more than that. So you could have 1, 2, or 3 steps. Each of these double arrows is essentially, within this flowchart, is essentially showing what those steps could be. However, there are that many and more other ways to do it that are wrong. Okay, so this flowchart, if you can understand what this is showing, that is, I think, the key to this section. There are lots of ways to do it wrong, but if you understand conversions and understand how to figure out where you're going, that I think is the key here. One thing I want to end with here, again, this is a very important section. The next section will not make sense at all until you understand this section. So please, before you move on to the next section, try out some examples. So try out these examples from within the textbook itself. Try out the worksheets that are on Canvas. Try out, if you need more practice, some of the homework from this section before moving on to section 4.4. So good luck, everyone. Again, please take this one pretty seriously.